Hi, good morning everyone. So this is me Vijay Kumar, Assistant Professor, Department of Electrical and Electronics Engineering. So today we will discuss about energy meter and then working principle of energy meter. So generally we have an energy meter, two types of energy meters are there, analog energy meter as well as a digital energy meter. So now we are discussing about analog energy meter. So this is one is for induction type energy meter. So this one is the analog energy meter. So I think many people are seeing in their home. So this is the old type. So nowadays they are replacing with digital energy meter in all the type of analog energy meters because of this has some sort of errors as well as we need frequent maintenance on this induction type energy meter. But the student should know the induction type energy meter first, then only they can easily understand what is meant by energy meter and then what is the working principle of energy meters. So this is the energy meter. So in this energy meter we have 4 points. So first one is phase neutral input as well as neutral phase output. So we need to give the electricity inside this 2 points as well as we can take it from the last 2 points. The phase, neutral and then neutral phase. This is the connecting order. So and also the energy meter in outward direction we have a dialing system and then some meters, speedometers like odometers are there. So in this odometer it will say how much amount of energy we are consuming. So this is what is the inside energy meters are there. So this inside energy meter we have two different coils are there. So this one is for voltage coil, it is nothing but it is called as a pressure coil. So this one is for current coil. So now we have a difference in voltage coil. We have a very thin wire, many number of turns. So this one is for voltage coil as well as pressure coil. So this is current coil. The current coil windings are very thick wire as well as it is very low turn compared to the pressure coil. And also we have a dialing system. So in this dialing system will shows how much energies are consumed. So this dialing system is connected to one gear wheel arrangement. So in this gear wheel arrangement is connected to common shaft. So in this common shaft is connected to disc. So disc arrangement. So the disc arrangement is floating with the support of pivot, upward side direction of pivot as well as lower pivot arrangement. So in this pivot arrangement will help this disc is allowed to rotate in a free space manner. Okay. So and also in the other components we have a shaded pole. This shaded pole is used to give some flex lines in very distributed manner as well as it will give some braking system and also it will act as a to avoid a damping systems. So working principle, when I am giving to the supply, first one this pressure coil will energized. Now the pressure coil will give some kind of flux lines to this area, this shaded pole area. And also when I am going to connect the loads, the current coil also get energized. So in this time the current coil also will give the flux lines to this disc. So we are comparing pi 1 flux from pressure coil, pi 2 flux from current coil. It will produce some resultant flux. That resultant flux produces some resultant torque. So based on the torque, the disc will starts to rotate. And also in energy meter, we are mentioning that 1500 revolution per kilowatt hour. That means when the disc is completed 1500 RPM, it will counted as a 1 unit or a 1000 kilowatt hour power consumed. So and also it is supplied by a 240 volt. So the disc rotation speed based on the load current. So that means the load coil or a current coil flux lines. So because the voltage is 240 volt, it is a constant. So the pressure coil will deliver only the constant flux lines, but in a current coil flux will vary based on the loads. For example, load is increases, the flux lines also increases. So based on the flux lines, pi 2 flux, it will get produces some high resultant flux. So that resultant flux allow to rotate the disc in very fast. For example, 1500 revolution it will complete within a 1 minute. So if load increases means 1500 revolution will completed less than a 1 minute. So this is how the energy meter is working. So thank you. For next class we will discuss in a real-time demonstration how the energy meter is working as well as how the digital energy meter is working. So thank you for watching.